Is the Earth actually flat? An intriguing question that has sparked debates for centuries. The theory of a flat Earth, a disk or plane in shape, is as old as human thought itself. From ancient civilizations to the modern era, this idea has found its proponents. Notable figures like Samuel Rowbotham in the 19th century fervently advocated for this belief, challenging the round Earth consensus. However, the round Earth theory has withstood the test of time, bolstered by scientific evidence. From the round shadow the Earth casts on the moon during a lunar eclipse, to the images of our planet taken from space, the evidence is overwhelming. Yet, the flat Earth theory continues to fascinate, provoking thought and debate. But what if for a moment, we entertain the idea that the Earth was flat? What consequences would we face? Let's delve into this hypothetical scenario and explore the repercussions of a flat Earth. If the Earth were flat, gravity would act very differently. Now that's a statement that might make you scratch your head. But let's delve a bit deeper to understand why. You see, gravity pulls everything towards the center of mass. For a sphere like our dear planet Earth, that center is in the middle. No matter where you stand, you're being pulled straight down towards Earth's core. This is why when we drop an apple, it falls straight to the ground, no matter where we are. But imagine if the Earth were flat. In this case, the center of mass would still be in the middle, but the middle of a flat disk, not a sphere. So, gravity would still pull everything towards the center. However, the further you move from the center, the more gravity would pull you sideways towards the center, rather than straight down. Imagine walking in this world. As you move away from the center, you'd start to feel as if you're climbing a steep hill, even on flat ground. You might even feel like you're about to tumble back towards the center. Now let's consider buildings. On a spherical Earth, buildings are constructed perpendicular to the ground, straight up and down, because gravity pulls straight down. But on a flat Earth, buildings would need to lean towards the center to counteract the sideways pull of gravity. Picture a city where all the skyscrapers are leaning inward, like a circle of dominoes set up to fall towards each other. And what about water? Oceans, rivers, rain, all would be drawn towards the center. A flat Earth would likely have a massive ocean in the middle with dry land around the edges. Rain would fall diagonally and rivers would flow uphill. So, a flat Earth would mean living in a world where gravity doesn't follow the rules we're used to. It's a fascinating thought experiment, one that helps us appreciate the peculiarities of our round home in the universe. A flat Earth wouldn't just affect gravity, but our climate as well. Imagine a world without the familiar climate zones we've come to know. No balmy tropics, no frigid poles, no temperate zones in between. This is what the Earth would look like if it were flat. Our planet's spherical shape plays a vital role in determining climate zones and weather patterns. You see, the Earth's curvature causes sunlight to hit different parts of the world at different angles and intensities. The equator, being the part of the Earth that's closest to the sun, receives the most direct sunlight, creating the hot climate we associate with the tropics. On the other hand, the poles, being farther away from the sun, receive less direct sunlight, resulting in cold climates. The Earth's rotation further influences our climate by creating winds and ocean currents, distributing heat from the equator towards the poles, and vice versa. This heat distribution is crucial in maintaining the distinct climate zones that support diverse ecosystems and life forms. Now let's flip the script and consider a flat Earth. Without a spherical shape, sunlight would hit the Earth uniformly. This would mean no distinct climate zones, no tropics, no poles, just one monotonous climate across the entire surface. But that's not all. A flat Earth would also disrupt wind and ocean current patterns. Instead of the orderly patterns we see today, we'd have erratic and unpredictable weather patterns. One moment you might be basking in the sun, and the next, you could be caught in a blizzard. Furthermore, the flat Earth's edge would likely be a place of extreme weather. It could be subject to intense heat, as it would be closer to the sun, or it could be freezing cold, depending on how the Earth is oriented in relation to the sun. In essence, a flat Earth would mean a chaotic climate, making life as we know it impossible. Navigation as we know it would be an absolute nightmare on a flat Earth. Imagine this: our current navigation systems, from GPS to old-school maps, are designed with the Earth's curvature in mind. Now flatten that sphere out, and what happens? Chaos ensues. Travel times and routes would be significantly affected. A straight line between 2 points on a globe isn't a straight line on a flat surface. This means that the quickest route between 2 points would no longer be the shortest distance. It would be like trying to solve a puzzle, but the pieces keep changing shape. Our entire transportation system, from air travel to shipping routes, would need a complete overhaul to accommodate this new flat world. Not to mention the astronomical costs associated with such a massive undertaking. So a flat Earth would turn our world into a navigational maze. So we've explored the bizarre and chaotic world of a flat Earth. We've delved into the gravitational anomalies, where we'd be heavier at the edges and lighter at the center. We've seen the climate chaos that would ensue, with extreme temperatures and unpredictable weather patterns. We've also navigated the nightmare of trying to plot a course on a flat surface, where East and West would cease to exist as we know them today. Alongside these consequences, we've revisited the historical debate about the shape of our planet. From the ancient Greeks to modern scientists, the consensus has been clear. The Earth is round. The fact that we've been able to successfully predict eclipses, sail around the world, and even launch satellites into orbit all stand as testament to this truth. And with that, we can confidently say that the Earth is not flat, and we should be very grateful for that fact.
Don't forget to like, subscribe, and share this video. That's all for Nifty Narrations.